Good morning and welcome to the May edition of the PHTV webinar. Today, we have the pleasure of having Rebecca Edwards and Michael Merchant from Ducks Unlimited Canada for today's presentation on Boreal wetland inventory and applications. Whenever you're ready, go ahead. Thank you.
Awesome, thanks. Yeah, I'll go ahead and share my screen. So I'll be the main presenter, but Michael is going to chime in with some good tidbits of information as well. So yeah, can everyone see my screen? Okay, is that good? Awesome. So yeah, so today a presentation is going to be a little mix of a story map, so a DUC wetland inventory and application for the webinar today, but it also will include some videos. So we've been recently working on some geospatial educational videos, so we're going to present those today as well. So I'll get started. So first, I would like to acknowledge that I am located in Nanaimo, British Columbia, home to the Coast Salish people of Snuneymuxw First Nation. Snuneymuxw territory encompasses one of the most productive and resource-rich areas in the heart of the Salish Sea, and I'm very thankful and grateful to be a part of this community. So first, a brief introduction. So of course, there's Michael and I, and we'll introduce ourselves. So my name is Becky Edwards. I am a remote sensing analyst with Ducks Unlimited Canada Boreal program. I work remotely out of Nanaimo, and I've been with Ducks for about 5 years, working on wetland inventories, mainly in the Northwest Territories. And Michael, you go ahead.
Sure. Thanks, Becky. Thanks, everyone, for having me today. My name is Michael Merchant. I'm a remote sensing specialist with the Boreal program. I'm calling from Burnaby, BC, so I'm also working remotely. And saying that, I would like to just give a quick land acknowledgement myself. So I would like to recognize that I'm on the ancestral and unceded homelands of the Hankaminam and Squamish-speaking peoples, and to extend my appreciation for the opportunity to be calling from this territory. And then just a little bit more on myself. So I have been with the National Boreal program for about 7 years now. And my role has, over the years, largely been team lead with a focus on wetland inventory development, but also research and development around mapping and monitoring using remote sensing, which is where I will chime in a bit in this presentation. And then also a little bit on my background. I am currently a PhD candidate at the University of Guelph, where I'm developing methods for Arctic tundra landscape monitoring, various scales, with a focus predominantly on AI. That's a bit of my background. I'll hand it back to you, Becky.
Thanks. Okay, so not only there's Michael and I who work on these products, but there's various other people. So we will call ourselves mappers, wetland experts, leaders, and maybe after today, policy influencers, maybe, I don't know. But here are various photos of all of us. Some of us who do work, Mark and Jamie in the field, our vegetation callers. We have us in the helicopter where we collect our field data, one from 2000, where we had actual physical maps with us in the helicopter. And now we have tablets, thankfully. We also just recently got certified for flying drones, which is also really cool. So now I'll just jump into what we've mapped so far. So DUC's National Boreal Program uses science-based approach to better understand boreal ecosystems. We work with government, industry, Indigenous peoples, academics, and other interested stakeholders. One of the main goals of the Boreal programs is to provide detailed and accurate wetland maps over the Western Boreal Forest. So this is the most updated map of our inventory. We have our enhanced wetland classification system in yellow, which is our completed, and Casca is one that I am currently leading and working on currently that will be an EWC product. And that is a 19 class wetland classification. Then we have our Canadian wetland classification system in green, which is our 5 wetland class system. We also have one running this summer or ongoing this summer in Clecho. And lastly is our blue, which is our earth cover classification, which was our older products and more of a vegetation classification than a wetland classification. And so a lot of these projects are developed for many different reasons. I thought I would because we're doing a policy webinar, maybe more focus on how it goes to influence policy. So how do our maps influence policy? Well, a lot of our Northwest Territory products, including Casca, the one I'm working on currently, are going to support Indigenous protected and conserved areas. So some of these include Adesi, Taidan and Nene are some of the current ones in the Northwest Territories. And like I said, ongoing is to support the proposed IPCA in Dene-Kusan, Casca in northern BC. And just another relevant example as well is the Manitoba wetland policy and how our maps have gone to influence that as well. So we like to say to protect wetlands, we must first know where they are. So the known net loss of wetlands allowed for 30 million hectares of habitat to be protected. And this was known because of our wetland inventory and our wetland maps. So this helps to identify how much habitat we can protect. And not only know exactly what wetland type, but how rare these species are, biodiversity, and many other spatial products as well. So now just to get into our wetland framework or how we break down our classification. So we first identify the 5 general wetland classes, the Canadian Wetland Classification System, which is broken up into peatlands or organic wetlands, which are bog and fen. And we have our mineral wetlands, which are swamp, marsh, and shallow open water. And this baseline wetland information will help build upon generalized assessments and large spatial modeling, for example. And then when we kind of break this down even further to identify 19 different wetland types in our enhanced wetland classification system, this is very useful for more complex problem solving, such as land use planning, wetland policy, and other complex conservation efforts. I will note that our enhanced wetland classification is unique to Duc's and the Boreal program and is one of the most detailed thematic wetland maps in Canada in terms of wetlands. And next, I'll just briefly go over to the 5 different types just to give you a better idea of what they kind of look like, what their characteristics are. First is bog, which is this kind of large circular peatland here next to the water body. The water is typically below the ground surface. You get a stagnant water flow, so it mainly gets its water flow from, or water inputs from precipitation. The top layer is moss and it feels wet and spongy, so that's that orange and yellow color, which is sphagnum moss. Trees are black spruce, and again, their shape is pretty identifiable as circular or teardrop shape. So in this area, you would get this whole circle of being like a tree bog, where these little pockets would be maybe shrubby or open bog. Next, we have fen. So again, as you can see here, this yellow sphagnum area, this is a bog in the corner, and in the middle is a large fen complex, which ranges from graminoid, shrubby, pattern fen of trees as well. And this scales kilometers in Decho territory in Northwest Territories. So the water table is at or below the surface. Water is moving and flowing and can range from nutrient rich to nutrient poor. And trees are black spruce, and a key indicator species is tamarack. You also get, just in this image here, just a large variety of species. Next, we have swamps, which is definitely one of the most difficult wetland type to identify and map because they tend to look a lot like uplands. But the swamps here in this image, this is in Wood Buffalo National Park, are these densely tree covered and taller treed areas. So they have fluctuating water tables where it could be extremely dry to being, knee deep in water. You will get formations of hummocks and hollows within swamps, and greater than 25% tree cover or shrub cover, and greater than 2-meter shrub height and 10-meter tree height. And that's how you kind of can differentiate swamps from fens. Next is marsh. So this is your classic wetland type. Water levels fluctuate during the year, but they're dominated by grass-like plants such as cattails and bulrushes. And lastly is shallow open water. So this is standing water up to 2 meters deep, but in our classification, all open water such as rivers, lakes, and streams are classified as open water, depending on kind of the pixel you're working with. And this includes submersed and floating vegetation. So I'm going to introduce our first video. So this is, we created 3 videos. The first one was a Wetlands 101, which is kind of what I just briefly went over now. And now I'm going to share our second video is really how do we create our wetland inventories using remote sensing and satellite imagery. So it's going to give a brief introduction to remote sensing and then talk about the different types of satellite imagery you use and how we come up with these wetland inventory products. In order to protect boreal wetlands, we must first know where they are. In this video, you will learn how Ducks Unlimited Canada uses remote sensing to map wetlands across the boreal. Ducks Unlimited Canada's Wetland Maps knit together and analyze remote sensing information to create large-scale, detailed pictures of boreal wetlands. The tools and techniques of remote sensing are becoming increasingly sophisticated and accessible, allowing information to be gathered quickly and in large quantities over vast areas. Wetland maps provide an invaluable tool to land managers who need to plan and anticipate wetland impacts from development or other landscape changes. Remote sensing is the science and art of gathering information about a place or object without being in direct contact with it. Remote sensing information is commonly gathered by overhead instruments, aboard planes, helicopters, and satellites. Remote sensing instruments can see wavelengths beyond those visible to the human eye. Some instruments measure the solar radiation reflected from the surface of an area or an object, giving us information about vegetation type and health. Other instruments emit their own energy and penetrate through tall vegetation and the forest canopy, revealing information about the moisture condition beneath the surface. One group of remote sensing instruments measure wavelengths in the visible and infrared portion of the electromagnetic spectrum. This is called optical remote sensing and is good for gathering information about vegetation type and health. For example, this is a true color composite image of a wetland complex taken by the Sentinel-2 satellite. A true color composite mixes the red, green, and blue bands detected by the sensor to create an image that is similar to what we see with the human eye. A false color composite is created by mixing bands both within and outside the range of what we can normally see. This image was created by mixing the near-infrared, shortwave infrared, and red bands. The different colors in this image highlight differences in vegetation type and density, as well as soil wetness. Another group of remote sensing instruments, called synthetic aperture radar, or SAR, emit and measure wavelengths in the microwave portion of the electromagnetic spectrum. At longer wavelengths, such as the L or P band, these instruments can travel through forest canopies and the ground surface and provide information about soil wetness and even permafrost. In this image, the two polarizations measured by the SAR instrument aboard the Sentinel-1 satellite are combined to highlight areas of flooding shown in the pink hues. In SAR imagery, the surface water appears dark as no energy is returned to the sensor, while flooded vegetation appear bright due to the energy being reflected first from the wet surface, then off the vegetation and back to the sensor. Light detection and ranging instruments, commonly called LiDAR, emit laser pulses and measure the time it takes for the pulse to return back to the sensor. LiDAR systems are extensively used aboard specialized aircrafts to measure topography. Topography can also be measured using multispectral or SAR instruments. This is an example of a digital surface model that provides a height measurement of the Earth's surface, including buildings and vegetation. Higher elevations or taller vegetation are shown in red, with lower elevations or vegetation in dark green.
Remote sensing information from these various sources is pulled together and analyzed using both computer learning techniques and the knowledge of experts, including scientists, Indigenous communities, government researchers, and industry partners. Ducks Unlimited Canada's wetland mapping methods use a technique called object-based image analysis. Object-based image analysis groups spectrally similar pixels into objects and assigns each object a land cover class based on collected field data. Research has shown object-based image analysis is an effective tool for mapping diverse ecosystems, such as wetlands. Here, the left two images show true and false color satellite imagery. The third image shows objects created by grouping similar pixels, and the final image on the right gives an example of the completed wetland map. Gathering field data allows analysts to develop a greater understanding of the landscape beyond the satellite imagery. The field data is also used to train the computer model and validate the wetland information mapped to reflect what's actually on the ground. When analysts visit a field site, they collect information about what vegetation is present, the estimated height of trees and shrubs, and other key features like standing water, hummocky ground, recent fires, and landscape position. This information allows analysts to determine the type of wetlands based on the Canadian Wetland Classification System, or Ducks Unlimited Canada's Enhanced Wetland Classification Data Model. Wetland maps refine our understanding of wetland characteristics and provide an invaluable glimpse into how wetlands function and interact across the landscape. Ducks Unlimited Canada's wetland maps form the basis of other spatial tools for mapping, managing, and conserving other key features in the Boreal. Mapping plays a critical role in conservation. Understanding where boreal wetlands are found, along with useful, timely, and consistent information about their characteristics, is key to managing and protecting them.
Great. I hope you enjoyed that. If you could tell, I was the one narrating. It's kind of awkward listening to yourself over and over and over again on these videos. So I hope that all made sense. And of course, if you need any clarification, just let us know from the questions. But overall, our wetland inventory products, like we mentioned, combine machine learning, field work to produce an overall wetland inventory. These results range from an accuracy of 80%, like greater than 80% for the 5 class, and about 70% or higher for the EWC. We also do manual editing in our products if needed, and this when it comes to if we know the area very well as wetland experts, if there's obvious confusion between wetland and upland types. Next video I'm just going to show, it's a 5-minute video on next what we do after our wetland maps are created and we hand them off to partners, what type of spatial tools you can build from this, which would include biodiversity, carbon, land use planning, and a little bit more. So I'll just play this short video as well.
Mapping plays a critical role in conservation. Understanding where boreal wetlands are found, along with useful, timely, and consistent information about their characteristics, is key to managing and protecting them. The detailed, spatially explicit information in Ducks Unlimited Canada's wetland maps is invaluable to many boreal applications, such as land use planning, wetland policies, scientific research, best management practices, and many others currently underway in regions across the Boreal. In this video, we explain how these maps serve as key planning tools, helping people who live and work in the Boreal make decisions and act as effective wetland stewards. DUC's wetland maps are used to locate either general wetland classes or more detailed wetland types, depending on the project, geography, and demand. Once mapped, this spatial information can be used to determine the underlying factors that form the wetlands. Maps that identify Canada's 5 general wetland classes, including open water, marsh, fen, bog, and swamp, are important for supporting baseline wetland information such as generalized assessments, large-scale spatial modeling, and other conservation efforts. However, DUC's more detailed wetland maps identify 19 different wetland types based on our unique classification system. These detailed maps are very useful for land use planning, wetland policy, and other important yet more complex conservation efforts. Each wetland class represented on this map reveals details about the ground, water, and climate that create it. These details, in turn, determine the plants and animals found in the area, as well as other natural and physical wetland characteristics. Analysts can determine several underlying factors from our wetland maps, including water flow characteristics, soil moisture, and nutrient status. Understanding the relationship between wetland classes and other wetland characteristics allow us to map these variables across a landscape. This information is vital to enhance our knowledge and provide useful recommendations to conserve boreal wetlands. Boreal wetlands are one of the largest and most important carbon vaults. They are the most valuable terrestrial ecosystem to help fight against climate change because they store large amounts of organic carbon beneath the surface, buried away in soils and peatlands. If these ecosystems are disturbed, stored carbon will be released back into the atmosphere. Ducks Unlimited Canada has been gathering carbon information from soil cores in the field and from published literature to better understand the volume of organic carbon within the soil throughout various types of boreal wetlands. This information, combined with our wetland maps, estimate the amount of soil carbon stored within peatland ecosystems. Ducks Unlimited Canada built its biodiversity mapping tool by studying how each wetland class is used as a primary or secondary habitat for wildlife, how each wetland class affects the number of species, and how closely they are associated with rare species. The tool uses correlation between wetland classes and the unique habitat characteristics relied on by mammals, birds, amphibians, and reptiles. The maps created from these tools provide insight on where species are potentially found and where biodiversity conservation efforts are needed most. The Western Boreal Forest contains the greatest number of wetlands and lakes in the world and supports around 10 million waterfowl each spring. We have mapped waterfowl in the Boreal Forest using wetland density as a strong predictor for species abundance. We have refined our waterfowl abundance maps by incorporating other information such as geology, wetland and upland vegetation classes, and measures of human disturbance. We work to achieve sustainable land use by informing and engaging with government, policies, and programs. We engage in land use planning processes promoting spatial decision support tools, such as MarkSand, to prioritize conservation activities in the Boreal. This is called systematic conservation planning, where one or more operation models design priority areas that require action. These tools give us the ability to understand the landscape in a unique way and provide various solutions to several different challenges through our modeling technologies. Ducks Unlimited Canada is involved in assisting and providing advice for land use planning processes across the Boreal region. We run models for various scenarios to provide conservation options for interested parties. Our conservation products, including wetland maps, spatial modeling, and decision support tools, are among many services we offer to land managers to help solve the challenge of sustainable, wetland-friendly development throughout the Boreal. Ducks Unlimited Canada's wetland maps are unique in forming the basis of other spatial tools for mapping. These resources are available on our website, along with more information about our wetland inventories and applications.
Awesome. Hope you enjoyed that as one as well. Also, if you like these videos and you want to use them or share them, get in contact with us because we can also do that as well. So now just coming towards the last couple slides here. Last thing I wanted to touch upon about our wetland inventories is how DUC is supporting innovation. So we've been working with researchers, Indigenous communities to link science to on-the-ground applications. As we mentioned before, our connections with Indigenous communities, but specifically the Indigenous Guardians Program. So this summer up in Casca, Michael and I have been working with the Cascadena to organize meeting up with the Guardians, collecting data, working together on this wetland inventory product. Another Indigenous-led conservation group we've been working with is the Indigenous Leadership Initiative, ILI. If you're curious to learn more about them, just Google that name. But they mainly talk about Indigenous Guardians Program, IPCAs as well. And so DUC's been working closely with them to enhance our program as well. And then Michael's going to jump in and talk a little bit about our NASA Above work we've been working on.
Yeah, thanks, Becky. I'll just be relatively quick here, but yeah, in terms of the slide you have up here in terms of innovation and R&D, it's been something with my role over the past little while in terms of leading the R&D for the National Boreal Program in terms of wetland mapping and being innovative. Just to kind of add to that, it's an incredibly important aspect with our program, just essentially because of the developments and advancements in remote sensing that we've seen over the past number of years. So my team and I, we've been working on testing various satellite and airborne data sets of various spectral, spatial, and temporal resolutions, and essentially reporting and documenting these results in the form of peer-reviewed publications, which essentially provide some credibility to our work to make sure our methods are sound. And one of those projects that is ongoing and we have been working on is the NASA Above project that Becky has just mentioned. So that involves us being engaged on NASA's Arctic Boreal Vulnerability Experiment campaign, so Above. And we have several partners on this project, including to the Southwest, the Michigan Tech Research Institute group, and also the NASA's Jet Propulsion Laboratory group. So a lot of really key players in this project, but essentially some of the key developments from this work is we were looking at developing temporal maps of wetland flooding frequency, which we were finding adds considerable information to our single time or static baseline wetland inventories. So we're finding and utilizing this information, or this dynamic temporal information, to improve things such as waterfowl modeling across boreal environments, which of course can have quite an influence on policies through conservation targeting. I think you have another slide.
Yeah.
Yeah, awesome. So just to kind of add a little bit to this as well. So like that slide kind of shows up there, many of our different methods pieces are published in the scientific literature, again, adding kind of a soundness and credibility to our work. But relative to one of the major innovative pieces that we're working on right now is what Becky has up here, which is our collaborative project with the Alberta Biodiversity Monitoring Institute, which is ABMI. And in terms of this project and being innovative, what we're doing is we're working towards developing the next generation of wetland inventories across Alberta. And what we're doing is we're relying on cloud computing resources to access enormous amounts of satellite data and AI algorithms to essentially process and analyze the data quite quickly. So it's quite an interesting and innovative project with quite a bit of support from the Alberta Environment and Parks. And then just relative to that, in terms of developing wetland inventories quicker, more efficiently, more accurately, we know that obviously wetland inventory data of those standards, things such as the Alberta Wetland Policy, which is where this work is being guided by. So we know that wetland inventories are important for policy around mitigation, avoidance, replacement, et cetera. And that's where the work that Becky, myself, and our other team members, where it comes in handy is wetland inventories influencing those aspects. So innovation, just kind of sum up there, is a quite an important aspect of our team, and especially within the field of remote sensing, which again is rapidly advancing.
That's great. Yeah, and I think to add to that as well, just having to be able to redo a classification that's over, how many years old is the Alberta one again?
Well, the Alberta Wetland Inventory, some on the call have probably heard of it. It's referred to as the Alberta Merged Wetland Inventory, or ABMI. But essentially, that data set is a mosaic of various time data sets. So wetland inventories that we had done dating back to the early 2000s. So obviously that data is dated. There's been changes, disturbance in the landscape. Resolutions of the satellite imagery are not what they are today. So yeah, updating is a very important aspect to support various pieces around policy.
Oh, awesome. Yeah, so that's the end of our presentation here. yeah, we would love any questions.
You can either raise your hand or type your question in the chat box.
Great presentation, Maggie.
Oh, thanks.
Always love the videos you got up there.
Thanks.
I'll throw a question to you. What's the next video, Becky?
Oh yeah. Well, we actually just met a couple, like literally yesterday, to discuss a new video that we're going to be working on. It's going to be more Indigenous focused, probably along the lines of kind of DUCs and the Indigenous led conservation that we've been supporting. So yeah, that's a new one, but it's like right in the works. But we're excited to do that and get some footage this summer in Casca and Clecho.
All right, we have a question in. Where can we watch the videos or share them with others?
Yeah, I will actually post them in the chat. I can also send them by email, but currently they are on YouTube, but they're unlisted under DUC. So I'll just share them in the group. And then, yeah, so then you can just share the link, and you can share them to other people as well.
There was a hand up. Did it came down? Maybe that was the same question.
Hi, yeah, it was me. I had put my question in the chat, so I took my hand down again. Thanks, everyone.
Oh, okay. Trent?
Question from Trent.
Yeah, thanks. Very good presentation, and certainly the I think a really good overview of how not just the work we're doing, do you see, with remote sensing and EWC, but also what we're doing with respect to Indigenous protected and conserved areas. And one of the things that I know we're looking at is drone imagery, which is mentioned. How many, I'm just curious, like how many do we have now? I should know this, but I don't. How many do we have in DUC Boreal that are now licensed drone pilots? And where would you be taking, where would you be working on next with our drone imagery?
Yeah, I will kind of mention that. So yeah, myself and Michael, and then 3 others. So 2 other GIS specialists, and then 1 conservation program specialists. We're all advanced pilots. So we just been, I think it was a couple weeks ago that we've just been certified. So that's great. And mainly for currently, we have 1 drone, and we're going to be taking it up this summer and kind of sharing it amongst the group to get really great imagery, just kind of like true color, like photos for marketing purposes currently. And Michael, maybe you want to talk about the other uses of drones and what maybe possibly in the future we can use with them.
Yep. Oh, now, yeah.
Oh yeah,
Sure.
go ahead,
Yeah,
take it
no,
away.
for sure. Yeah. No, Becky's covered it quite well. A lot of the purposes currently are those like really nice images of those of nadir above type viewing angles, which are really great for marketing purposes and communication that we otherwise couldn't really get from from on the ground. So that's where we really see the use of it right now. Obviously, there is a whole nother field of UAV remote sensing in terms of capturing deeper sets of data. We're not getting into that yet, just because our main goal and purpose from within the DUC Boreal program is to establish wetland inventories at quite a large scale. At that point, UAVs don't really apply to those to the scales that we're working at, but we could see down the line some use for different drone sensors that capture greater data for more localized type mapping. So someone needs very, very high resolution products, whether it's classifications or other different landscape parameters that we could be measuring. That could be something that we look into. It might be a topic down the road, but that's kind of a whole nother game. But it's an exciting field if we did want to get into it.
Matt, go ahead.
Hey, Mike and Becky, thanks for a great talk. It's always interesting to hear about all the remote sensing work you guys are doing. I was curious, you kind of mentioned a little bit about some of the temporal aspects to your work. I was curious what your thoughts are on like the state of the science or where remote sensing technology is right now to start assessing some of that. And so I'm thinking in the context of like forest regeneration, or wetland extent, like water extent changes at these larger spatial scales. Like, are we going to be there soon? Are we there yet? Or what's the outlook look like?
Yep, I'm going to take that, Becky.
Yeah, go ahead.
Sure.
Or,
yeah, great question, Matt. And yeah, feel free to pop in your thoughts too, Becky, afterwards. But yeah, the state of the science within our field is rapidly advancing. One of the things that's really helped with looking towards developing products that are multi-temporal rather than static or single timestamp like baseline inventories is the fact that we have access to cloud computing resources, which reduce our strains on local machines. We're able to access petabytes of data for processing. So that's opening up new opportunities for us. And I'm saying that because it's connecting directly to the NASA above work that I talked about in terms of using satellite data to map flooding frequency of areas over time. That's one really useful impact of where the science is right now. Currently, that work is focusing on a targeted area, but we'd like to have those methods developed over larger scales where we can combine them with the baseline inventories that Becky has talked about, because when you have that really good land cover data mixed with the temporal information, you can really start predicting things like waterfowl abundance and other aspects quite accurately. So it's really, really useful information, and it's a sign of where the field is. So that's one of the aspects of where remote sensing is right now, is that we're starting to move a bit away from desktop-based processing to cloud computing, but also within the cloud, we're having access to many more satellite data sets and airborne data sets that we really didn't have access to before. So I'll make one little quick note relative to that, but space agencies in particular over previous decades, for example, a lot of their products were commercial. They weren't really open access. Now we're seeing even the Canadian Space Agency and other space agencies open up a lot of their data because that's the business model that's actually working for them. They're seeing quite a large utility with groups like ours for land cover mapping and flooding frequency mapping, et cetera. So yeah, we have access to cloud computing resources. We have many new data sets. So one more point there is that's where the importance of working on R&D within our program comes in. We want to make sure that we are understanding how to harness these different technologies and data sets to the best of our abilities for wetland mapping and monitoring purposes. But it's a very, very exciting field right now with all the different advancements that we're seeing.
Yeah, I'll also just chime in too and say, like, my background in my master's was time series analysis, and I've just been itching to get a project related. So, and hopefully, and like Michael was mentioning, like with the cloud computing, anything you can do on Google Earth Engine now with time series analysis has opened so many doors, because normally you'd have to download each of those images and process them. And so, yeah, the R&D is important, and we're excited to like get more into that aspect of it, because a lot of like the Canadian Forest Service, like Mike Walder and his group, they're doing amazing work with Landsat, different imagery, looking at forest disturbance over time. It would be really interesting to get into that with wetlands as well.
Yeah, for sure.
Okay. Looks like we don't have any more questions. I'd like to take this opportunity to thank Michael and Becky for their great presentation today. If you do have any more questions, please feel free to forward them to myself or John, and he'll forward any questions on. Again, thanks you everybody for attending the May PHJV webinar, and we look forward to seeing you in our next webinar. Thank you, everybody, and have a great day.
Thanks, everyone. Thanks, Ian.
Bye. Thank you.